Welcome back. This is section 6.2.3, which is your compound interest. So today we will be talking about compound interest. We did see how simple interest works. The word itself tells you it's pretty simple. In compound interest, the word itself is telling you you're compounding more than once. Let's just say I take $100 loan from you with 10% interest, and I'm going to take it for 2 years. If I'm using simple interest, I'm going to pay you the interest for the $100 every year. But in compound interest, you are compounding the interest on your interest. So what do I mean? If I take $100, at the end of the first year, you will have $110 in your bank. But the second year, I'm not calculating the interest for the $100 that you put in. I'm calculating the interest for the 100 and the $10 that you got from the interest from the previous year. So what's happening here is you're calculating interest on top of interest. That's why it's called compound interest. All right, let's go ahead and take a look at the formula here. The formula is AT. Again, please make sure you have these formulas ready when you're working with these problems. It's very important. AT is principal amount P times parentheses 1 plus R stands for rate and N stands for the number of compounding periods in 1 year. How many times you're compounding it in a year. We're going to go ahead and take a look at those kind of problems as well. To the power N times T. Keep in mind you will be using your class calc to calculate all of these, so you should not worry about any of them. All right, let's go ahead and work on the first problem. Okay, Jamie placed $2,800 in a savings account, which earned 4.3. Like I said, every time I see something of my interest, I simply go ahead and highlight it. So she placed $2,800 in the savings account and she earned 4.3. And be very careful in the test. I will not test you based on topics, but I'm just gonna scramble up all the questions. So you have to go ahead and find out what is a compound interest, what is a simple interest. So here, when I read the problem, Jamie placed 2,800 in savings account, which earns 4.3% interest compounded annually. So I know it's a compound interest. That's the key word. How much will she have in the account after 13 years? That's a lot of time. Again, I'm going to start with my basics. Do I have the principal amount? Yes, I do, which is 2,800. Do I have the rate? Yes, which is 4.3. Remember, I changed that to a decimal, so 0.043. Do I have N? What does N stand for? Number of compounding periods in 1 year. So they say compounding annually. That means I'm compounding once a year. So my N is 1. And time is in years, which is 13 years. So what I'm going to do is I'm going to go ahead and plug this into the formula. So my P is 2,800, open parentheses, 1 plus. My R is 0.043 divided by N, which is 1, times 1 times 13. I'm going to go ahead and plug the entire expression into class calc. So let me go ahead and show that to you. Da, 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 da. Here is my class calc on the right hand side. And here is my problem. So what I'm going to do is I'm simply going to go ahead and plug this in. So 2,800, open parentheses, 1 plus 0.043 divided by 1. Use your arrow to the right. Close your parentheses. To the power is a power n. 1 times 13. So as you can see, I simply went ahead and plugged in the formula into my class calc, and the amount that I got is 4,840 cents, 0.096727. They ask you to round off to the nearest dollar. Sometimes they ask you to round off to the nearest cents. That is 2 decimal places. When they say round off to the nearest dollar, you're going to give me the entire dollar amount. So according to this particular answer, my dollar amount is 4,840. So that is my dollar amount. So she invested $2,800 13 years ago with 4.3% interest. After 13 years. This is what she got. Now let's go ahead and take a look at the next problem. All right. Jocelyn placed let me reduce the ink. Okay. Jocelyn placed 4,000. Again, if I see something, I highlight it so I know that's the point of interest. Jocelyn placed $4,400 in a savings account, which earned 3.2% interest compounded annually. How much will she have in her account after 12 years? The keywords are the principal amount, the interest, and compounded annually is the keyword. Once I know that, I'm simply going to go ahead and plug in my p-value. What is my p-value? It is 4,000. I didn't like the ink. It is 4,400. The rate is 3.2%, so change that into decimal. 0.032. N value compounded annually, so N is 1, and the time is 12 years. All right, simply go ahead and plug it into the formula. My formula is P, which is 4400, parentheses 1 plus my R is 0.032 divided by N times 1 times 12. I'm simply plugging it into the formula. So R is my rate, N is N is 1, time is 12 years. Again, it's the same concept. I'm simply going to go ahead and plug that into my class calc. Let me move this to the side. Clear this up. That's the best practice. Always clear up what you have. 4400, open parentheses, 1 plus 0.032 divided by 1. I don't have to do divided by 1, but it's always a good practice to make sure you know how to use those operations. To the power is a power n. Bingo. Open parentheses, 1 times, that's not, 1 times 12, close parentheses, and I have $6,421.10. Rounding off to the nearest dollar, I'm going to go ahead and use this. So my final answer is $6,421, rounding off to the nearest dollar. All right. Now let's go ahead and look at one more where it's not compounded annually. Let's bring this up here. All right, there we have it. Now n is the number of compounding periods in 1 year. So if I say I'm compounding semi-annually, your n is going to be 2 because you're compounding every 6 months. If I say monthly, I have 12 months, so my n is 12. And if I say quarterly, my n is 4 because I'm compounding every 3 months. But if I say weekly, please make sure you read the instructions because some problems gave you 51 weeks and some problems gave you 52 weeks. So here I put 51 comma 52. So depending on the problem, you might want to pick what they specified in that particular problem. All right, so let's go ahead and take a look. If $500 is borrowed with the interest, again, let me pick my highlighter. $500 is borrowed with the interest of 21%. That's a lot of interest. Compounded. I know it's a compound interest. monthly. Let me change the highlighter color so you can see. So this is monthly. So I know I'm using n is equal to 12. What is the total amount of money needed to pay it back in 1 year? Okay, once I have this, I'm simply going to go ahead and plug into the formula. It's exactly the same formula. The principal amount is the amount I started with, which is $500. My rate is 21%. That's a lot. Change it into decimal, 0.21. N is how many times am I compounding? They said monthly. So monthly, my N value is 12 from right here. And time is 1 year. Probably that's why they charge 21% because they're just taking it for 1 year. I'm going to go ahead and plug this into the formula. 500 parentheses. Let me move this. 1 plus R. Oops, not R. My R value is 0.21 divided by 12 to the power 12 open parentheses 12 times 1. Again, you're going to go ahead and plug this into the class calc. Da-da-da-da-da. Move it to the side so I can see the numbers. Clear it. That's the good practice. So let's go. 500 open parentheses 1 plus 0.21 divided by 12 right arrow close parentheses to the power is a power n open parentheses 12 times 1 which is 12. So $616.78. Here they asked me to round off to the nearest cent, so let me go ahead and use that. It is $616 and rounding off to the nearest cents, which is 79 cents. So that is my final answer. All right, let's go ahead and take a look at the next one. Again, these problems are pretty simple. All you have to do is make sure you know what they're asking you for. It's compounded monthly, annually, is it simple interest? Once you know that, plug into the formula, plug into your class calc, and you're good to go. All right, let's go ahead and take a look at the next one here. An account is opened with the initial deposit. Let me go get my handy dandy highlighter. An account is opened with the initial deposit of $700 and earns an interest of 3.3%. Compounded semi-annually. What will the amount be worth in 3 years? All right. I'm going to go ahead and plug that in. Principal is 700. The rate is 3.3%. Keep in mind, 3.3% in decimal is 0.33. Sorry, 0. I think I forgot a 3. Let me erase this. 0.033. My N value semi-annually, so let me scroll this up. Always have this in your note card. Semi-annually is 2, so my N value is 2. N is 2, and the time is 3 years. I'm simply going to go ahead and plug into the formula. 700, open parentheses, 1 plus 0.033 divided by 2, which is my N, open parentheses, 2 times 3. Again, your N is 2, right? Your R is your rate, and your time is 3. Once I have this, I will go ahead and plug it into my class calc. There is my handy dandy class calc. Clear it, and let's go ahead and plug in 700, open parentheses, 1 plus 0.033 divided by 2, right arrow, close parentheses, a to the power n, open parentheses, 2 times 3. So I end up with $772.22. Rounding off, $772.22 because they asked me to round off to the nearest cent. Fair enough? All right. Now let's go ahead and look at another kind of computation, which is compounding continuously. So before I go ahead and talk about that, where is my worksheet? Am I missing my worksheet? No, right here. So this is 6.2.4, you're compounding it continuously. So what does it mean continuously? Continuously means every second, every microsecond, every minute, every hour. You might miss, how does that even work? So let me go ahead and talk a little bit about this one. Da-da-da-da-da, where is it? So here I have it on my right hand side. Let's just say you take $1 from me at the interest rate of 100%. So if I compound every day, I'm compounding the interest every single day for a whole year, then it's going to be 2.71. If I compound every hour, it's going to be 2.718. If I compound every minute, as you can see here, every minute, this is what I have. Every second, continuously. So as you see, the number is getting closer and closer to 2.71828182818281. That's an irrational number, and that number is not, how do I call it? That number is represented. That number is represented by a letter E, which is called, or which is invented by a great mathematician called Euler. You have to see the mathematician. So this is the great mathematician Euler who has invented this number E, which is 2.718281828, so on and so forth. So this letter E is used in the formula of how to compound your interest when you're compounding it continuous, like every second, every microsecond. All right? I had to show you this mathematician because, we know the formulas, we know everything, but it's always nice to see who is behind it. Just all mathematicians, don't they look great? All right, let's go ahead. Let me have my class calc ready, and let me jump right here. So this is what the problem is. So when you're compounding continuously, again, this will be specified in the problem. You have to look for the keywords. So here I have it. This is the formula for compounding continuously. A is equal to P times E. E stands for Euler to the power RT. Now let's go ahead and take a look at this problem here. All right. So Jessica placed $1,100 in savings account, which earns 3.7% interest. Again, the keyword is compounded continuously. Always look for your keywords. How much will she have in the account after 10 years? I will go ahead, take my pen. Where is it? Right here. The p-value is 1100. The rate, interest rate, is 3.7. Percentage always to decimal, 0.037. Time is 10 years, right? And if you see, there's no n here because I know I'm compounding continuously. I'm simply going to go ahead and plug this into the formula, which is 110 times e to the power, always open parentheses, 0.037 times 10 and close parentheses. All right, let's go ahead and plug this into class calc. Let me move this to the side. Da-da-da-da-da. Good practice, clear what you have before. 1100 times, you see this little e on the bottom here? E to the power, which is a power n, open parentheses. I want you all to be very careful when you're plugging in. One simple mistake, your entire answer is messed up. What am I looking at? Yeah, 0.037 times 10 close parentheses. Okay, so when you compound continuously, I'm rounding off to the nearest dollar. Again, be careful what they're asking you for. My final answer is 1,593 because it's more than 50 cents. 0.5, I'm going to round it up. That is my final answer. So my amount after 10 years is 1,593, $1,593. All right? Okay, now let's look at the next problem. Tim has an investment account in which, my handy dandy tool, in which compounds interest continuously. So always look for the keyword that says compounding continuously at the rate 1.6 for 5 years. So after 5 years, he wants to know he has 2400 in the account. How much money did he initially place in the account? So this is we're going backward direction. So Tim has an investment. So after 5 years, Tim has $2,400 in his account. And they're asking you if after 5 years, this is what Tim has, how much did he start with initially? So let's go ahead. So we have the final amount, A. So after 5 years, how much does Tim have? 2400. The principal amount, how much did Tim start initially? That's what I'm looking for. Do you see that? He says, how much money did Tim start with initial amount? That's the one I don't know. So I'm going to put a question mark. The rate, 1.6. So 0.016. The time is 5 years. I'm simply going to go ahead and plug it into the formula. So A, 2400 equal to P, I don't know what P is, E to the power 0.016 times 5. So what I'm going to do is I'm going to plug this into ClassCalc and see what this value is first. I want to see what e to the power 0.165 is. Again, I'm going to move this. All right, clear this up. Remember, I'm only looking at what the highlighted value is. So e to the power, open parentheses, 0.016 times 5, close parentheses. And what is that equal to? Let me go ahead and pick my pen. So I know I always pick the wrong pen. 2400 equal to P. I just found out this e to the power 0.016 times 5 is nothing but 1.083. I'm going to keep it to 3 decimal places. Now to calculate P, all I have to do is divide both sides with 1.083. Divide with 1.083. I'm going to go ahead and plug that into my calculator. 2400 divided by 1.083. So what amount did he start with? Tim started with, let me move this up. So Tim started with 2,200, nearest dollar, 216. How do I know this is correct? Because your initial amount is always smaller than your final amount, because remember, you're getting paid interest, so you always get more than what you invested. So here, just by looking at the numbers, I know they look reasonable. I invest $2,216. After 5 years, I get $2,400. That is reasonable. But if you get 20,000, 30,000, then you always have to take a step back and see, does that even make sense? I invested $20,000 and I got $2,000. That's not right. So always read what the problem is asking for and then work your problem out. Again, if you have any questions, please let me know. You can contact me through email or Teams, and good luck.